At 3,800 meters below the Atlantic, the pressure is hard to even imagine. Down there, the ocean pushes on every surface at once with unbelievable force. That was the environment Titan entered every time it dived, and for a while, the hull held until it didn't. Because this story didn't begin on the final dive. By the time Titan disappeared, the damage may already have been building inside the hull for years. Most deep-sea submersibles are built from metal. Titan was different. OceanGate used carbon fiber for the main body of the vessel, lighter, cheaper, and incredibly strong in certain conditions. But deep ocean pressure is unforgiving. At that depth, the hull wasn't being stretched outward. It was being crushed inward over and over again. Every dive put stress on the hull, down to depth, back to the surface, again and again. And with each cycle, tiny weaknesses inside the carbon fiber could grow a little larger, not visible from the outside, not dramatic at first. Just microscopic damage slowly spreading between the layers of the material. Over time, there were signs that something wasn't right. Wrinkles appeared on parts of the hull surface. Cracking sounds were detected during dives. Former employees raised concerns about the safety of the vessel. And looking back now, those warnings feel difficult to ignore. Because in structures like this, damage rarely appears without a reason. To most people, a wrinkle on the hull might not seem important. But in carbon fiber, surface changes can point to something happening deeper inside the structure. The outer layer starts reacting to stress it was never supposed to carry. And once that starts happening, engineers begin asking a very uncomfortable question. How much strength has already been lost? As the dives continued, the hull kept communicating in another way. Sound, tiny acoustic emissions caused by cracks growing inside the material under pressure. At first, isolated events, then more frequent, more energy, more stress, more damage accumulating beneath the surface. And then, on the final dive, the signals stopped. At some point during the descent, the remaining structure could no longer handle the pressure around it. The implosion happened in milliseconds. No slow flooding, no dramatic countdown. Just a sudden structural collapse powerful enough to destroy the vessel almost instantly. At that depth, there was no time to react. When investigators recovered the debris, the wreckage revealed something important. The titanium sections were damaged, but mostly intact. The carbon fiber hull was shattered into countless fragments across the seabed. The two materials failed very differently, and that difference helped investigators understand where the disaster began. The most unsettling part of the Titan disaster is that many of these risks were already known. Engineers had studied how carbon fiber behaves under repeated deep-sea pressure for years. The warning signs were understood. The concerns existed. The questions had already been raised, which means this may not have been a failure of knowledge. It may have been a failure to listen. The ocean never gives second chances at 3,800 meters, and in the end, the Titan hull left behind a record of everything that happened to it, in the cracks, in the fragments, in the damage hidden inside the material itself. Long before the final dive, the structure may already have been telling its story. The tragedy is that nobody fully understood what it was saying until it was too late.